Hello, this is Mr. Stone, and in this video we are going to learn about distance and displacement. By the time you're finished watching this video, you should have learned about the difference between distance and displacement. So to start off, let's describe what distance is. It is often defined as the distance between 2 points, being the length of the path connecting those points. Distance is something a bit more common to us. We often describe it as how far away something is. The other concept we call displacement is defined as the difference between the initial position and the final position of an object. And we measure this as a straight line distance between those 2 points. There are 3 fairly common types of displacement when we talk about motion. One is known as the crow flies. We could also have displacement that is the same as distance, and we could have examples of when displacement equals 0. To explain displacement as the crow flies, we have this example of this park with a fountain in the middle, and we want to get to the other side of the park. So we have to walk around the fountain to get there. But the displacement is that straight line from where you started to where you end up. Let's try this example of looking at displacement as how the crow flies. For example, you take a road trip from Los Angeles, California to New York, and to drive there you'll have to take 7 different interstates, which total 2,791 miles. The actual distance between the 2 cities is 2,445 miles. Now try to find your distance and displacement. On this map, we can see our total distance represented with the blue line is 2,791 miles that we drove to get to New York from Los Angeles. But the displacement, that straight line from Los Angeles to New York, is 2,445 miles. So here, our displacement and our total distance are different. There are times when the distance and displacement will be the same. In this example, we can see that a person has walked in a straight line in just one direction. So that's why we have distance and displacement as the same. Here's another example to try. Usain Bolt ran the 100 meters during the 2012 Beijing Olympics, and his time was 9.63 seconds. So you're asked to find what Usain Bolt's distance and displacement was for this race. Because he ran in a straight line in only one direction, we can see both his distance and his displacement will be 100 meters. The third type of displacement we're looking at is when the displacement equals 0. In this example, we can see the person has walked all the way around the fountain and finishes where they started. Remember that displacement is the difference between the initial position and the final position. So since the start point and the end point is the same, the displacement equals 0. Give this final example a try. During the Bristol NASCAR night race, the drivers complete 500 laps on a 0.533 mile concrete oval track for a total distance of 266.5 miles. You're asked to find the car's distance and displacement during this race. Because the car traveled 500 laps, the total distance was 266.5 miles. However, since the starting line and the finish line are at the same point, the displacement of the car is 0. To review those 3 types of displacement, remember the first one is where the distance and the displacement are different. The distance could be longer, but the displacement is this straight line between the final point and the starting point. The second example is when the displacement and the distance is the same because the object traveled in a straight line in one direction. The third type of displacement is when the displacement is 0 because the object started and finished in the exact same position. I hope this video helped for you to understand better the difference between distance and displacement and those three